Exponents and order of operations. Exponential notation. The expression b to the n, where n is a natural number, means b to the n is equal to b times itself as many times as you have n, which is a natural number. So first, let's make sure we understand what natural numbers are. And those are the numbers contained in the set 1, 2, 3, 4, and so on. The base is b, and the exponent is n. Let's try some examples. What number is the exponent of 2 to the 4th? The exponent is the digit 4. What number is the base in 2 to the 4th? And the base is 2. Number 2, expand and evaluate 2 to the 4th. Expand means to write it out. So we have 2 times itself 4 times. Then to evaluate it, we need to multiply. 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. Number 3, use symbols to write 5 squared. Your base is 5, and your exponent is 2. Squared means 2. Number 4, use symbols to write 7 cubed. 7 is your base, and cube means 3, so 3 is your exponent. Number 5, write the product as an exponential expression. So how many times do you have the number 4 being multiplied by itself? So our base is 4, and 4 is being multiplied by itself 5 times. So that is 4 to the 5th. And number 6, write the product as an exponential expression. The base is W. How many times is W being multiplied by itself? 6. So that is W to the 6th. In the following examples, you are being asked to write down the base, the exponent, and evaluate. Number 7, 3 squared. The base is 3. The exponent is 2. To evaluate that, that is 3 times 3, and 3 times 3 is equal to 9. Number 9, don't ask me where number 8 went. Number 9, the base is 4/5. The exponent is 2. So that tells us that we're multiplying 4/5 times 4/5, which is equal to 16 over 25. Number 10, the base is -4. The exponent is 2. This means you have -4 times -4. -4 times -4 is equal to a positive 16. Number 11 is very different than number 10. The base is 4. The exponent is 2. This is asking you to find the opposite of 4 squared. This is like saying -1 times 4 squared. It could be written as the opposite of 4 times 4. Well, 4 times 4 is 16. The opposite of a positive 16 is a negative 16. Pay particular attention to these two. They are very different, especially when you're putting them in your calculator. Number 12. What is in parentheses is the base. So the base is -4. The exponent is 3. That means we have -4 times -4 times -4. And we multiply those together, we get -64. Number 13 is the opposite of 4 cubed. The base is 4. That exponent of 3 only goes to the base of 4. To evaluate this, again, this is the opposite of 4 times 4 times 4, which is -64. And you can see when you have an odd exponent, 12 and 13 are the same. But it's very different when you have 10 and 11. Your answers are not the same. 12 and 13, your work is not the same. Notice the base and notice the exponent. All right, next we're going to look at order of operations. The order of operations. Number 1, perform all calculations within parentheses and absolute values or above and below a fraction bar. Next, evaluate all exponential expressions. Number 3, do multiplication and division left to right as they appear in the problem. Step 4 is you do addition and subtraction from left to right as they appear in the problem. So division doesn't always come before multiplication. Multiplication does not always come before division. It depends on how the problem is written. So let's practice. Number 1, we have 5 plus 4 times 6. Well, we're going to multiply and divide before we add or subtract. So the first thing we're going to do is multiply the 4 times 6. So this would be 5 plus 24. And then we add, subtract left to right as it's written in the problem, just like how we read a book, left to right. So 5 plus 24 is 29. Number 2, 6 times 7 minus 8. Multiplication and division come before addition and subtraction. So we'll take 6 times 7 and get 42. 42 minus 8 is 34. Number 3, 6 divided by 3 plus 2. We're going to divide before we add. 6 divided by 3 is 2. And 2 plus 2, 4. Number 4, we have 100 divided by, 100 minus 50 divided by 5. So we are going to do division first. So we're going to 50 divided by 5 first, and that is 10. So we have 100 minus 10, which is 90. Number 5 is all division. You are going to divide left to right as it occurs in the problem. So the first thing we'll do is take 20 divided by 5. That is 4. So we have 4 divided by 2, and 4 divided by 2 is 2. Number 6, 3 plus 2 to the 4th. We need to do exponents first. So 2 to the 4th is 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So we have 3 plus 16, 19. Number 7, 4 times 2 cubed. Exponents need to be calculated first. 2 to the 3rd is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So this is 4 times 8. 4 times 8 is 32. Number 8, we need to calculate what's inside parentheses first. 4 plus 1 is 5. So this would be 5 cubed. 5 cubed is equal to 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. Number 9, we're going to add 4 plus 8, which is 12. We'll add 1 plus 3, and we get 4. 12 divided by 4 is 3. Number 10, 10 minus 3 squared. So we need to calculate 3 squared. That's 3 times 3, which is 9. So we have 10 minus 9 in the numerator over 2 times 4 squared. 4 squared is 4 times 4. So this is going to give us 2 times 16. We'll put that there. That says 2 times 16. 10 minus 9 is equal to 1. And 2 times 16 is equal to 32. Number 11, we need to do things in order. So we need to work within the parentheses first. So I have 10 squared minus 30 minus 2 times 5 is 10. So that would be my first step. My next step is to work within the parentheses. I have 10 squared minus 30 minus 10 is 20. Next, I'll do the exponent. 10 squared is 10 times 10. So that's 100. 100 minus 20 is 80. Number 12, we have 1/2 to the 4th. So that's 1/2 times 1/2 times 1/2 times 1/2. Again, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So this is 1 over 16. I'm going to go ahead and simplify my fraction. 5 plus 4 is 9. So that's 9 over 3. 9 divided by 3 is 3. So this is 1 over 16 plus 3. And when you're adding fractions with the same sign, this is the same thing as 3 and 1/16. If you're not comfortable with fractions, you can, of course, put this in your calculator. And it's possible that on your homework, my labs would want this as a fraction and not a mixed number. And if that's indeed the case, we can take 1 over 16 plus 9 over 3 if you wanted to on your calculator, or you can take 16 times 3 plus 1. Either way, we're going to, oh shoot, we get 49 over 16. There you go. All right, the next little thing is a little comic. Depending on how old you are, you may or may not know the game of operation. But it says, no, not the plus sign. You got to take out the parentheses first. All right, just a little comic relief before we finish up here. The next part is we want to translate the phrases into mathematical expressions and then evaluate them. Number 13, 5 squared plus 9. 5 is your base. Squared plus 9. So that's our expression. Now we want to evaluate this. 5 squared is 25. And 25 plus 9 is 34. Number 14, 30 decreased by 4 times 3. 30 decreased by 4 times 3. You could use a dot or you could use parentheses for multiplication. Don't use an X since you're in algebra class, and an X is going to stand for a variable. Again, we're going to do multiplication first. So we have 30 minus 12, and then 30 minus 12 is 18. Number 15, 10 cubed divided by 5 squared. 10 cubed divided by 5 squared. Or you could write it as 10 cubed divided by 5 squared. Both of these are the same thing. Ten cubed is 1,000. 5 squared, 5 times 5 is 25. And 1,000 divided by 25 is 40. And either way works great. And number 16, 5 times the quantity 2 plus 3. So it's 5 times the quantity 2 plus 3. It's not 5 times 2. It's 5 times the quantity 2 plus 3. So work inside the parentheses first. 2 plus 3 is 5. So then we have 5 times 5, which is 25. There you go.